So this is the topical papers for the carbonyl compounds. Some reactions of compounds P, C5, H8O are shown. Give the structures for organic compounds Q, R, S, and T. In Q, this is your ketone, and also this is your alkene, and you're going to reduce it. This is your reducing agent. Hydrogen in the presence of nickel catalyst, this is your reducing agent. So you would be getting your secondary alcohol, okay? And you would be getting your alkane. You would be getting your alkane, okay? And then in R, they are saying compound P is going to be reduced by this reducing agent. NaBH4 is also your reducing agent, but this is a mild reducing agent. This is your mild reducing agent. So it can only reduce ketone into secondary alcohol. Okay, this is your mild reducing agent. So I would be getting secondary alcohol only. And what is S? Cold acidified potassium manganate. Cold acidified potassium manganate. So I told you that cold conditions can only give you diol. Cold condition can only give you diol. I mean this. The pi bond would be breaking down. Okay. The pi bond would be breaking down and you would be getting your diol. Rather than if you would be having your hot KMNO4, if you would be having your hot KMNO4, the whole double bond would be breaking down. I can say the rupture of double bond, and then accordingly you will be getting, sometime you will be getting your aldehyde, sometime you will be getting your carboxylic acid, sometime you would be getting your ketone. So it depends. It depends basically. And if you can see T, if you can see your T, so T means that this is iodoform test. Okay, this is your iodoform. I told you in iodoform reaction, iodoform basically is uh, you can say that carboxylate ion is produced. And what would be compound T? So ultimately compound T is your iodoform, that is CHI3. That is CHI3. So this is I, this is I, this is I. I'm not supposed to make it just like that. This is CHI3. Okay, this is your skeletal formula. I'm not supposed to show hydrogen in this. I'm not supposed to show hydrogen in this. Give the systematic name of PE. Give the systematic name of PE. So what am I supposed to write? That what is your P? So P is this. P is this. So क्या कहते हो? What is supposed to be? Hmm? Any idea? Hmm? IUPAC naming. I told you. What was the rule? You are supposed to select the longest carbon chain, and then you are supposed to give the least number to your functional group. In this compound, you have two functional groups. The first group is your ketone, and the second group is your alkene. So, to which group you are going to give preference? Alkene or your ketone? क्या कहते हो? हाँ जी. So that I can give the least number and then I can say that this is the name of a compound. So first of all, you have to decide Okay, what is your preference? What is your preference? Hmm? Yes, Simona, Tala, Iman. What do you
Sir, will
think?
it be pentan 2 on?
Pentane 2 on. What are you saying?
Sir, because the double bond will be on the second carbon.
Means that you are giving preference to the alkene rather than
Okay.
ketone. Am I right?
Yes, sir.
So means that this should be 1, then 2, then 3, then 4, and then 5. Right? Okay. So how many carbon atoms you have? 5 carbon atoms. You have 5 carbon atoms. So, but if you're going to give the number from your right hand side, your alkene is getting the least number. But in fact, you are supposed to give the preference to your ketone. You are supposed to give the preference to your ketone basically, okay? So it should be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is pent, pent 3-ene, pent 3-ene, okay, and 2 on. E comes first alphabetically. This is your alphabetical order. Ene comes first. E for E elephant. This comes first as compared to this oxygen. So this is your IUPAC naming. Rather, else you can also write that 3-pentene, 3-pentene and 2 on. 3-pentene and 2 on. You can also write this. 3-pentene 2 on. This is your name. What would you observe when compound P is reacted with 2,4-dinitrophenylhydrazine? I told you that 2,4-DNPH test
The
is a
red
specific,
precipitate.
yeah, exactly, to check the presence of carbonyl group. To check the presence of carbonyl group, so we would see the red precipitate. If the carbonyl group is there, so we would see the red precipitates with this 2,4-DNPH. Then the reaction of hydrogen cyanide with propanol. Propanol is this. In the last class, we did this reaction. This is your nucleophilic addition reaction. This is partial negative. This is partial positive. And cyanide is going to attack on that carbon atom. So they are saying give the full name of mechanism of this reaction. So this is nucleophilic addition. Nucleophilic addition. So yeah, easy. Now they are saying to complete this mechanism, ultimately this is partial negative. Okay, this is partial positive. Cyanide has a lone pair of electron. That's why it has a negative charge. It would be attacking on this carbon. It would be attacking on this carbon, since you know that the carbon is going to have maximum 4 bonds. Okay, so when this cyanide is approaching this partial positive carbon, so they are going to repel each other. In order to avoid repulsion, this double bond is going to be broken down, and oxygen is going to take electrons. As you know that oxygen is highly electronegative element. Then what am I supposed to do? I would be writing just like that. Now this oxygen is having full negative charge with a lone pair of electron. Okay, then this is your CH3. This is CH3. Cyanide is attached. Okay, so this is your H positive ion. This is your H positive ion. I'm supposed to write down over here. So it would be attacking on this H positive center. And finally, it would be forming this. Finally, you would be forming this. That's called nucleophilic addition reaction. Okay, that's called nucleophilic addition reaction. Then they are saying give the systematic name for acetone. Systematic name for acetone. Again, you are supposed to give the preference to the ketone. Okay, when you have alcohol and ketone in the same compound, so your carbonyl would be the preference, would be your preference. So you are supposed to give the least number to this carbonyl. So you have in total three carbon atoms. Uh, it would be 3 hydroxy prop 3 hydroxy. You have four carbon atoms, right? 3 hydroxy butane 2 on butane 2 on 3 hydroxy. Third position per you have OH group and second position per you have carbonyl compound. So it would be 3 hydroxy and butane 2 on. Identify the reagents and conditions necessary for the conversion of acetone into diacetyl. You know what's going on in this? What's going on in this? This is your 2-degree alcohol, 2-degree alcohol. And what is this? This is ketone. This is ketone. So secondary alcohols can be oxidized into ketone. I am supposed to use oxidizing agent, that is your potassium dichromate. We can also write Cr2O72 minus /H plus, okay, and heat under reflux. Heat under reflux. If a sample of acetone is reacted with concentrated sulfuric acid, a single product is formed that does not exhibit stereoisomerism. There are two types of stereoisomerism, optical and cis-trans. You can say geometrical isomerism. However, if a sample of acetone is reacted with HBr, a mixture of pair of stereoisomers is produced. Give the structural formula of the product of the reaction of acetone with concentrated sulfuric acid. You all know that concentrated sulfuric acid जो होता है, it's a dehydrating agent. What is this? What is this? It's a dehydrating agent. It's a dehydrating agent. So in your structure, that is your acetone. Okay. When you are going to add concentrated sulfuric acid in this, so it would be giving you alkene. It would be giving you alkene. How? You can see किस तरह से वो alkene देगा आपको. Okay. I'm going to make the structure 3 hydroxy and butane 2 on. Mhm. Mhm. ये एसीटोन था, right? 3 hydroxy butane 2 on. So 1 2, oh my god, wait. Mhm. Yes. चलो मैं यहीं से ही बता देता हूँ, ये देखो. See this. This is your carbon. This is your carbon having three hydrogen atoms, and this is your one hydrogen. When you are going to add concentrated sulfuric acid, this OH and this H would be removed. This OH and this H would be removed to give you alkene, to give you alkene, and the alkene should be like that. The alkene should be like that. Okay, क्योंकि सल्फ्यूरिक एसिड जो था वो डिहाइड्रेटिंग एजेंट था, इट्स गोइंग टू रिमूव वाटर मॉलिक्यूल फ्रॉम योर कंपाउंड. That's why you're getting alkene, because the water is removed, because you have added the dehydrating agent. So give the structural formula of the product. So I'm getting CH3, CH3, CO, okay, CH3, CO, and then CH double bond CH2. तो ये आपका एल्कीन बन गया. ओके, सो इसमें पॉइंट वाली बात क्या थी कि दिस डिहाइड्रेटिंग, ये देखिएगा, why the product in one, why the product in one, one कहाँ गया, why the product in one does not exhibit stereoisomerism. This product is not going to have stereoisomerism. So of course there would not be any chiral center, because if you have chiral center, so means optical isomer is possible. But if you don't have any chiral center, optical isomer is not possible. Okay. So what am I supposed to write for this? What am I supposed to write for this? That it's not going to give you optical isomerism, but they are using the term stereoisomerism. Stereoisomerism includes both optical and also the cis trans. Uh, Also, it's not going to give you the cis trans isomerism, because I told you the two conditions for the cis trans isomer. Number one was that you must have a double bond. You must have a double bond. Not only this, the different groups are attached on the same carbon atom. The different groups are attached on the same carbon atom, remember. Okay. So I would write that, I would write that one would not show cis trans isomer as same atoms are attached, just like that. Okay. And there is no chiral center. There is no any chiral center. Due to this, why the product of reaction of acetone with HBr does exhibit stereoisomerism. तो आप इसका एक काम करो. You are supposed to do the reaction of this acetone with HBr, and the product is going to give you the stereoisomerism. तो सिस ट्रांस तो नहीं देगा because you would not be having double bond. Okay, double bond तो खत्म हो जाएगा ना. So then we have to see, we have to mention the uh, like chiral center. Okay, so let's see. मैं उसका रिएक्शन करवा रहा हूँ किसके साथ, HBr के साथ. It's going to be plus HBr, and this is your product. तो ये आ गया. I'm supposed to attach Br over there according to the Markovnikov rule, if you remember. Oh my God. Okay. Can you hear me? Do you have my screen? Do you have my screen?
Yes, sir.
Okay. मेरी last बात क्या सुनी थी? Yes. Have you listened that I was saying that why this compound is going to give you the stereoisomerism because it contains a chiral center. After drawing the product, after the reaction of this reactant with HBr, the product is going to have a chiral center, that is this. And if you have a chiral center, so it's going to give you the optical isomerism. This is like it's a type of stereoisomerism. And in the next part, he's saying that if the optical isomer is possible, then you are supposed to draw the structure. If the optical isomer is possible, then you are supposed to draw the structure. So see this, it's carbon, it's bromine, it's bromine, it would be CH3CO, it would be H, it would be CH3. Now, the mirror image of this is CH3, H, and this is CH3Cu. ये इसका ऑप्टिकल आइसोमर है. इट्स वेरी इजी, इट्स वेरी इजी. ओके, चलें जी. देन कहता है कि कंप्लीट द रिएक्शन मैकेनिज्म फॉर रिएक्शन 5, include all relevant lone pairs, curly arrows, charges and partial charges. So means that this is partial negative, this is partial positive, has a lone pair of electron, it would attack on this partial positive carbon. This bond is going to be broken down just like the previous reaction. Now it has lone pair of electron with a negative charge. Rest of the things are the same. This is H. The cyanide is attached. Okay. The cyanide is attached. और ऑक्सीजन का चार्ज यहाँ बना देता हूँ. Then it's H positive and it's going to attack on this H positive and you will be getting your product. This is your mechanism in which I have included the curly arrows, the partial charges, and the lone pair. Okay, all are included in this reaction. Again, this product is going to have a chiral center because this is different, 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 different. Again, it's asking to draw the optical isomer. So, see this? I'm supposed to draw the 3D diagram. Okay, OH. No, it's CH3, CH2. Okay, it's H. तो just आपको कुछ नहीं करना. You are supposed to draw the mirror image. The same thing, left, right, and right, left. Same structure. Okay. Hopefully you will do this. This is the last questions that we are going to do. Then inshallah we are going to start the next topic. Okay. A, B, C, D, E, and F are all structural isomers with the molecular formula C4H8O. They are saying they all are structural isomers of each other. Structural means structural isomers have three types: chain, positional, and functional group isomer. A, B, and C are all given orange precipitate with treated when treated with 2,4-DNPH. What does it mean? के सब में क्या है? Carbonyl है. They all are carbonyl. You know, A, B, C all give an orange precipitate means that carbonyl is confirmed. Carbonyl may be aldehyde and carbonyl may be ketone. Okay. But according to the given statement, this is confirmed that they all contain carbonyl group. But only A and B give a brick red PPT when warmed with Fehling solution. Now we are in doubt, like I know that they are going to give us the positive test for the carbonyl compound, but what the carbonyl compound is, whether it's aldehyde and whether it's ketone, what is this? So furthermore, they are going to confirm that only A and B give a brick red precipitate when warmed with Fehling solution. So A and B only they are aldehydes. क्यों? कि they are going to give the positive test for the Fehling solution. Okay, draw the skeletal formulae of A, B, and C. Okay, you know the molecular formula, that is C4H8O. You know the molecular formula, that is C4H8O. So they all are structural isomers of each other. You know, I would be drawing first skeletal formula, na? Uh, this is your A, okay, and this is your B. Both are aldehydes, okay, with 4 carbon atoms. and C is this. I can make it ketone. कितना easy है देखो, बिल्कुल baby topic है ये. Name the type of structural isomerism shown by A and B. Structural isomerism shown by A and B. ये तो बता सकते हो, I think. It's very easy. What do you think? What's this? What is this? Mm-hmm.
Positional isomerism.
Uh, Position is the same. Aldehyde की position you can never change. This is the functional group that is always present on the extreme corners. We cannot change. We can only change ketone. We can change the position of alcohol, but we can't change this. Remember, it's a concept. Yes, it's a nice question. Manji, so this
Chain,
is
I
called
suppose.
chain. Exactly. This is chain. This is chain isomerism. This is the chain isomerism. Okay. चलें जी आगे. What you would see when a sample of A is warmed with Tollens reagent, Tollens reagent. So I would see that the silver mirror is formed. I would see silver mirror. I would see silver mirror is formed because this is the positive test for aldehyde. We have two tests, Fehling solution and Tollens reagent. D, E, and F all decolorize bromine means that they have alkene, means they have carbon-carbon double bond. That's why they're gonna decolorize bromine. And effervescence slowly with sodium metal. Oh, okay. Sodium is going to react with alcohol and also it's going to react with carboxylic acid. Since they have given you the molecular formula, in that formula you have only one oxygen atom, it shows that there is no carboxylic acid. It shows that there is no carboxylic acid. So, of course, no, they are saying effervescence slowly with sodium metal. It shows that it has an alcohol. Okay, because alcohol contain only one oxygen. E shows geometrical isomerism, means that E has a carbon-carbon double bond and the different groups are attached. Okay, that's why it's going to give you geometrical isomerism. Only D has a branched chain. None of these isomers contain an oxygen and bonded to carbon atom uh, involved in pi bonding. None of these isomers contain a chiral center. Okay, give the structures of D, E, and F, show the two stereoisomers of E, and label the stereoisomerism shown. Okay, so according to the given statement, I'm supposed to draw the structure of D. They are saying has a branched chain. What they are saying has a branched chain. Okay, and of course, it's supposed to contain alkene group and also the OH group and also the OH group and one branch. So only four carbon atoms we have. What I would be doing, I would be making the chain for the three carbon atoms because I have to make the branch as well. So this is your branch. मैंने आपको क्या कहा था कि branch कभी भी corners पर नहीं होती है. It's impossible to have a branch on the corners, whether you have extreme right or left. Branch is always present on the mid ones. It may be present on two, on second, on third, on fourth, on fifth, etc. Okay, it is a double bond. Okay, and this is your alcohol. Though this structure is possible structure. Okay, so due to the presence of this OH is going to give you the positive test for sodium, like it's going to give you effervescence. Or since you are going to add bromine water in this and it contains an alkene, so bromine water will decolorize. Okay. And what is E? E shows a geometrical isomer. इसका क्या मतलब है? The double bond should be the double bond should be in between. Like you can say we have to we have to put the double bond on that carbon atom that it would be having the different groups attached on the same carbon atom. So I'm supposed to do just like that. Okay, this is your carbon carbon double bond. Four carbon atoms we have. Out of four, I need to do this. One, two, three, and this would be fourth carbon, and this is your hydrogen. This is the possibility that I can make. So why it's going to give you cis trans isomer, or you can say the geometrical isomer, because you have a double bond and the different groups are attached on the same carbon atom. That's why. Okay. Okay. So this is the trans. Why this is trans? Opposite side. Opposite sides. I'm going to draw the cis isomer for this. Cis isomer is very easy. You are just supposed to the same thing. बस मैंने इसको यहाँ से twist कर दिया. Okay. Now what about F? What about F? Uh, F is also going to have like is also going to decolorize the bromine water. Okay, it's also going to decolorize the bromine water, means that it has a double bond. Or or there is no branch. There is no branch. It's a long chain structure, but it must have a OH as well because it's going to react with the sodium metal. तो मैं इसी स्ट्रक्चर को मैं यूं बना रहा हूं देखिएगा जरा 2 3 4 and then OH. Okay, this is of 5 marks. Then identify the gas produced during the reaction of each of these isomers with sodium metal. ये भी कोई पूछने वाली बात है. Hydrogen gas. Hydrogen gas. Another compound G, C3H8O, contains the same functional group as A. A में क्या था? A में you had aldehyde. Okay, aldehyde. Give equations for the reactions of G with each of acidified potassium dichromate and sodium tetrahydro uh, hydrodo hydroiodoborate, or you can say sodium borohydride. Okay, it can be represented by this H reaction with acidified potassium dichromate. What I told you, if you are going to have your aldehyde and you are going to oxidize it by using potassium dichromate, it's a mild oxidizing agent as compared to KMnO4. So you would be getting your carboxylic acid. That would be C3H6O2. C3H6O2. Okay. And then it's a reducing agent. You have aldehyde, it would be reducing into what? Primary alcohol. It would be reducing into what? Primary alcohol. This is your reducing agent. So aldehyde can be reduced into primary alcohol. So primary alcohol means like hydrogen is also added in this. So that would be C3H8O. That would be C3H8O basically. Okay. Else you can draw the structure to confirm this. Let me draw the structure. It's C3H6O, right? It's an aldehyde. One, two, three. It's an aldehyde. It's C3H6O. I'm going to oxidize it to make it carboxylic acid. That would be just like that. That would be just like that. Yes. Okay, this is your carboxylic acid. Now you are supposed to calculate the formula. It's C3H1234 1 2 3 4 5 6 7. कोई मिस तो नहीं कर रहा मैं? 6 and then again O2. That's why I have written this C3H6O2. Okay, or this is your reducing agent, and you have aldehyde. So aldehyde can be reduced into primary alcohol again. Aldehyde can be reduced into primary alcohol again. Primary alcohol again. Remember. Okay. So that's the formula for primary alcohol. That's all about the carbonyl compounds. You are supposed to do more questions. And then if you are having any difficulty, then do let me know. I would be telling you that how to do these type of questions basically. Okay.